So good afternoon and welcome back, everyone. Today's lecture is about review on application of first and second order ordinary differential equation. And I just have three main points for this review. So the first is the application of first and second order ODE as low pass filter. I will begin with it. You have seen before that the first order ordinary differential equation can be obtained from physical systems such as RC circuit, as you can see here. So for this system, you have input voltage as DC voltage and output as V out at the capacitor. If you derive the mathematical modeling for the system, you get the first order differential equation. So now we look at the property that this system behaves like a filter. Okay? So the term low pass filter means, so this is low pass. Low pass filter means all the high frequency input will be filtered out. Okay? High frequency signal from the input will be filtered out. Only low frequency exists. Can pass through the system. So look at here. First, you observe the response of the system first. In here, before the system is started, the contact K is at 0, which means the supply voltage to the system is 0. And then the switch K is switched to 1 here, which means you supply DC voltage to the system, and you start to set the timer. So the time count from 0 at here, where K is 1. And then the input of the system would be a constant at value VDC. And the output of the system would be like something like this. Okay, it's first order. So what happens if you switch the K on and off very fast? For example, you do it at the frequency like 200, which means, okay, let's say 100, easy. 100 hertz, so it means the period would be 0.01 second. Just example. So you switch on and off very fast. Then the response of the system would be something like this. I can draw here. Yeah, something like this. Okay. So the faster the frequency you choose, the smoother the output of the voltage. Okay. So this is kind of filter. What happens if you okay, so what is the application for this kind of system? So let's say you want to provide input voltage varying from 0 to VDC. You can just play around with the duty cycle of this one. So we're going to see in the simulation together. So yeah, this one is called duty cycle. Okay, another case. Okay, this one already explained. We have a pulse as input, and the output will look like, yeah, just like this, right? It depends on how. Okay. Another scenario is that you have a signal of the input corrupted by some noise. So you can see here, the pure signal is supposed to be like this. Okay. Supposed to be smooth like this. But if the signal is corrupted by noise, then the filter system can also filter out the noise. The output, the expected output should be something like this. Okay. So both first order and second order can behave like a low pass filter like this. I just give another example of first order. You can obtain from a motor, DC motor, where you ignore the value of inductor. Because usually inductor is very small, with a scale of like millihenry or even 0.1 or 0.001 millihenry, so very, very small. You can ignore it, then you can derive the dynamic equation for DC motor to be just first order in terms of phi dot, in terms of angular velocity. Okay, in terms of angular velocity, the equation is first order, but in terms of position, it is second order. So in here, I'm going to show a simulation for DC motor where the input in the form of pulse, okay, like this. Then we can see the output. Okay, but first we start with the RC circuit. The equation looks like this. V out dot equal to minus 1 over RC V out plus V in. Okay, like this. So let's simulate the first order system using using ITC-DCLab. So you can use either ITC-DCLab or MATLAB to simulate the system. So now you can use your PC and simulate it to see how this first order can behave like a filter.